Welcome back, everyone. Thanks for joining me again. In this video, we're going to evaluate this indefinite integral. So before I evaluate this, I want to tell you the method we're going to be using. We're going to be using a trigonometric substitution. This integral can be evaluated by use substitution, but we're going to do it differently so that you're familiar with different tools. Usually, if you have such expression, let's say, if you have an expression like sum a squared minus x squared. If you have this expression, then you're going to use the substitution x equals a sine theta. And then you can proceed from there. Or if you have the expression, let's say x squared minus some a squared in your integral, then you're going to use the substitution x equals a secant theta. Lastly, if you have an expression such as x squared plus a squared or a squared plus x squared, you're going to use the substitution x equals to a tangent theta. So these are the three forms we look for in our integrand if we want to use this method, which we call it the trigonometric substitution. The idea is to rewrite the entire integrand in terms of the theta variable instead of the x variable, because it's easier to work with. Now, for this particular problem, I see that I have a square root and I have this expression, which matches the one of the expression we wrote down on the right side. It looks like that form. So let's go ahead and rewrite it so that it looks exactly like sum a squared minus x squared. So I'm going to go ahead and do that. So we have the integral x over a square root of 9 can be written as 3 squared minus x squared dx. So now I see that this is my a, that's my x. So I'm going to make the following substitution. We're going to let x be equal to a sine theta. So that will be 3 sine theta. Once you do the substitution, you want to replace everything in your integrand instead of theta variable. So I need to replace dx. That means I need to find the derivative of the substitution I came up with. Dx is going to be the derivative of x, which is 3 cosine theta d theta. So you're going to replace x with 3 sine theta, dx with 3 cosine theta d theta. So let's check this out, what it looks like. So once I make the substitution, my integral becomes, so x is replaced with 3 sine theta. Dx is replaced with that piece right there, 3 cosine theta d theta all over. Now on the denominator, we have 3 squared, that's 9, minus x squared. Well, x is 3 sine theta, so that's 9 sine squared theta. So that's what it looks like in our integrand. So you see how we had everything in x variable, we translated into a different variable. Now we go ahead with integration. Now, before we do that, we need to simplify. So let's simplify this as much as we can, since it still looks like something we're not able to integrate. So I'm going to rewrite. So I have 3 times 3. So we have a 9 on the numerator. Then you have sine theta times cosine theta d theta all over. On the denominator, you can factor out the 9. So you have 1 minus sine squared theta. Now, here is something useful to remember. We know the identity sine squared theta plus cosine squared theta is 1. So I see this form in that identity. So if I simply solve for cosine squared theta, I get 1 minus sine squared theta. That's what I'm going to replace right in here. So check this out. So my integrand becomes, this is the integral of 9 sine theta cosine theta d theta all over. Square root of 9, I can simplify that to be a 3. And then we have the integral is square root of cosine squared theta. Now here, I can cancel out the square root with the square in the denominator. So I get, and also I simplify these. So I have a 3 sine theta cosine theta d theta all over absolute value of cosine theta. Remember, when you cancel the square with the square root, you have to put an absolute value. Now, we're going to restrict that cosine theta is positive for theta between negative pi over 2 to pi over 2. So keeping that boundary for theta, I can drop the absolute value. So with that information, we can drop the absolute value, and now we can freely simplify this further. So you have 3 sine theta cosine theta over cosine theta d theta. And now I can freely cancel these factors. So our integral simplifies to just 3 times the integral of sine theta d theta. Now this is easy to evaluate. We know how to evaluate this. This is simply negative 3 cosine theta plus c. The integral of sine is negative cosine. So that is our answer in theta variable. But remember, your original question was given in the x variable. So we need to retrieve the x variable in the answer. And we're going to get it from here when we made the substitution. So we made the substitution that x is equal to sine 3 sine theta. So that means I know that sine theta is equal to x over 3. So from this, we can construct our right triangle where theta is an acute angle. So let's place it right here. Sine, we know this is going to be opposite over hypotenuse. So across from theta is your opposite. So this is hypotenuse. That means this side, using the Pythagorean theorem, will be the square root of hypotenuse squared minus the other leg squared. So that's 9 minus x squared. And now we can read off what cosine ratio is from the triangle. Cosine is adjacent over hypotenuse. So this is negative 3 times adjacent. That will be a square root of 9 minus x squared over hypotenuse 3 plus c. And again, we can simplify our answer by canceling out the 3's. So you have negative a square root of 9 minus x squared plus c. So that is the new method of integrating. You can use this for almost any integral that has that 3 specific form we mentioned beginning of this video. So I hope you enjoyed the video. Try it out with the substitution because you can actually do this integral by use substitution. All right, see you next time.